Today we have counting, and this is just the number of ways that something can happen. This is like the sample space. How many ways can a coin flip come out? How many ways can two coin flips come out? And so on. And there's two important parts that come out of it. One is factorials, and the other is the binomial distribution. The reason we do it is for the binomial, and in passing we get factorials. Get Excel going. Pick a spot. I'm going to go to the middle here because that way you can see it. And we're going to have three things, A, B, and C. And we want to know how many ways these things can come about. So the first thing is with replacement and or order matters. Right? We got three things, A, B, and C. And if we have A, B, C, A, B, B, all possible combinations, there are three ways to choose the first one, which is A, or B, or C. There are three ways to choose the second one, and there are three ways to choose the third one. In this, we've got first A, and A. To do these easily, go to that third column and put in an A, B, and a C. Then copy down for that A. Then we need to copy the A, B, and C and paste it. So we got A, and then we can have AAB, AAC. Then this one can be B, three B's. This is just the easy way to make sure we got all the possibilities. Any one of the three things with repeats and order matters, so that AAB isn't the same as BAA. So that these things can be repeats. And then here we get C, C, and C. Copy that and then paste it in there. Then go to the A, B, and C. We need more of those. Copy them. Then paste it. And then paste it again. Over here, we got A, B, and C, three things. A, B, and C, three things in the second place. And A, B, and C, we got 27. So we're going to do 1 and 2, and then I'm going to use the fill command to copy these down. Series, step 1, and I only need 27. So I've got A. I need AAA all here. So I have AAA, AAB, AAC, ABA, ABB, so on. Then this is going to be all B. and it goes to 18. Then this one's going to be C's. And this is just how many ways we can arrange these things. Now I'm missing something. What am I missing? I only got 2 A's. Hopefully you got it right. All right, so there's the ways that this can go. Mark the columns, a couple of columns at the top, and I'm going to change the column width. So if I mark them all at the top, column width, and I want it to be 6, just so it's smaller. And also I'm going to make all of these centered, just because it's easier to look at. All right, so I've got A, B, and C, all possible combinations. Order matters, and I can repeat. All right, now I want to take out the repeats so that I can't have AAA or AAB. Anything that repeats has to come out. And I make a mark in there just so I can keep track of which ones have a repeat. This one repeats. A, B, B. A, B, C doesn't repeat. A, C, A, I have a repeat. A, C, B, no repeats. A, C, C. A, B, A, B, A, B. There's another one, BAC, that doesn't have a repeat. Then BBA, BBB, BBC. All of these have repeats. There's a BCA that doesn't have a repeat. Then this one, I have BCC, CAA, there's CAB, no repeats. CAB, CBA, CBB is a repeat. This is a repeat, or has a repeat. CC, 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 CC. How many should I have left that are unmarked? I can't repeat. I can put anything in the first position. So I can put A, B, or C in the first position. In the second position, I can only have 2 things. The other of the A, B, C. And once I've got A, B, or C in the first one of the 2 left in the second one, then there can only be 1 at the end, so that there will be 6. So I should have 6 places open, and they should all be some combination of A, B, and C. So I've got A, B, and C, ACB, BAC, BCA, CAB, and CBA. 1, 2, 3, 4, 5, and 6. If I take out repeats, I get 3 possible in the first position, 2 possible in the second position, and 1 possible in the third position. This is like the degrees of freedom. You got a pencil box, it's got 3 pencils in it. One person has 3 choices, the next person has 2 choices, the next one has 1. And this is called a factorial. And it's written with an exclamation mark. All the good math symbols were taken up years ago. So anything newer has pretty wimpy stuff. So n factorial is equal to n times n minus 1 times n minus 2, n minus 3 on down to 1. So 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And it's the number of ways I can arrange n objects without repeating. But order matters. A, B, and C is not the same as B, A, and C. This is in Excel equals FACT. So FACT is factorial. And whatever number I put in there, it's going to do n times n minus 1 times n minus 2 and so forth. So if I do 3, I get a 6. If I had 4, I'd have to multiply that by 4 equals FACT. And that's 24. And these get big fast. Equals FACT 10. 10 factorial is a really big number. 3,628,800. That's a factorial. It is n times n minus 1 times n minus 2 on down the line. This is order matters. With no repeats. The next thing we have is to take out the order. So if you go back to here, then we have A, B, C, and everything else that is unmarked is some version of A, B, and C. So we only have one thing that we can do. We've taken out the repeats and we've made the order unimportant, and we're left with one thing. The deal in all of these is, can we allow repeats and does order matter? Now we have this is called n things taken k at a time. If we have A, B, and C, and we only want 2 of those things, then first one can be A, B, or C. There's 3 possibilities. The second one, I have 2 possibilities, and I have 6 total. And we could do the whole list of A, B, C, and all that, but this one, we have A, B, A, C, B, A, B, C, C, A, C, B. If I take out the order, A, C, and C, A are the same. B, A, and A, B are the same. So I've got A, B, A, C, B, C, and the last one is that repeated. So I only have 3 things. What this becomes is permutations. We have n things. We want to take k at a time, and order matters. No repeats and orders matters. You're having Christmas dinner or something, and you've got 10 people that are possible invites, but you only have place for 5 of them. Out of the 5, one is Uncle Ralph and the other is Aunt Doris, and they can't stand each other. So if they are invited, you can't put them together. The order matters. I got to keep them separated. Permutations I can calculate as n factorial divided by n minus k factorial. This is why we need the factorial. The n factorial is all the ways we can get the first person, the second person, the third person. N times n minus 1 times n minus 2 and so on. The n minus k takes out repeats. So we can't have Aunt Doris in 2 seats. There's one Aunt Doris, she's got to be in a seat. So we have no repeats. This is permutations. And if I have 5 things taken 3 at a time, this is written P 3, 5. Permutations of 3 things out of 5. And, excuse me, got it wrong. The permutations is written 5, 3. P, N, K. Not this. 5 things taken 3 at a time. Order matters, no repeats. So 5 things taken 3 at a time is 5 factorial divided by 5 minus 3 factorial, which is 5 times 4 times 3 times 2 times 1. 5 minus 3 is 2, so we have 2 times 1. This goes there, takes that out, and I have 60 ways I can get 3 things out of 5 without repeats, but order matters. So that's a permutation. And in Excel, this is equal to E equals PERMUT. Permutation, permute in Excel. And I have to give it the number of possibilities and the number chosen. 5 things taken 3 at a time. 5, 3. Enter, and I get 60 ways that can happen. That's permutations. Order matters, no repeats. And this is combinations. And this is how many ways we can take n objects, k at a time, without repeats, and order doesn't matter. We're flipping a coin 3 times. We can get a head, heads, or heads. Or heads, heads, and tails. Or we can get tails, heads, and heads, and it's the same thing, except the order is different, and we don't care. All we want to know is how many ways can we get 2 heads if we flip a coin 3 times. This is how many ways something can happen. How many ways we can roll dice and get 1/6 out of 5 rolls. Roll the dice 5 times. How many ways can we get a single 6? How many ways can we get 5 6s? How many ways can we get 4 6s? This is what we need to do when we want to know how many ways a particular thing can come out, no repeats, and order doesn't matter. AB is equal to BC. Just like in the Excel list, order doesn't matter. So if we had 3 coins, we flip a coin 3 times, how many ways can we get 2 heads? This is calculated as n factorial over n minus k factorial. That's the permutations, and we want to take out order. That becomes k factorial. So 3 coins, 3 factorial, over 3 minus 2 factorial, and 2 factorial is 3 times 2 times 1, divided by 3 minus 2 is 1, and 2 factorial is 2 times 1. Those cancel, and I'm left with 3. So if I flip a coin 3 times, how many ways can I get 2 heads? I can get a heads on the first and second, heads on the first and third, heads on the second and third. 3 ways. What we want to have is how many ways n things taken k at a time. Boy, that got weird. N things taken k at a time, and this is combinations. And this is the way it's written in statistics. N things taken k at a time, and I put brackets around it. On a calculator, it's nk. Sometimes this is written nx or combinations nx. And if you look on a calculator, they have combinations and permutations, and this is the way the keys are labeled. So it is n factorial over n minus k factorial over k factorial. And these get big fast. If I wanted to have ten things taken 5 at a time, I'm going to flip a coin 10 times, and I want to know how many ways I can get 5 heads out of it. This is 10 factorial over 10 minus 5 factorial divided by 5 factorial. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1, because I have 10 minus 5, and again I have 5 times 4 times 3 times 2 times 1. This cancels. Didn't mean to get the 6 in that. I can divide 2 and 5 and take out the 10. I can take out the 4 and leave 2, and I can take out the 3 and leave 3. So I've got 3 times 2 times 7, which is 3 times 2 times 7 is equal to 42. This is the way we used to have to do it. Go back to Excel. Equals COMBIN is combinations in Excel. And then it tells you what it wants. the number and the number chosen. Here it's going to be 10 things, 10, comma, 5, and there is, did I get it right? Oh, I left out something in the calculation. The 6. 3 times 2 times 7 times 6 is equal to 252. I flip a coin 10 times. How many ways can I get 5 heads? What's the chance of getting a head or getting a tail? It's 1/2. Now, if I go to dice, I want to know how many ways I can get a 6 5 times. Flip the coin 10 times. How many ways can I get 5 6s? The probability of a 6 is 1/6. The probability of a 7, anything, is 1, or not 7, 1 die, 1/6. What's the probability of not getting a 6? 1/6 to get the point I want, and 5 6 gives me everything else. Now the probabilities aren't equal, and this is what we have, and all of this goes for this is the binomial distribution. The binomial is literally 2 names. Binomial. The outcomes are this or that. 1 or 0. Left or right. Up or down. Blue or red. Heads or tails. Or a particular number compared to all the other possible numbers. P is equal to the probability of success. If I'm rolling 2 dice, what's the probability that I get a 7? What's the probability that I get an 11? Success is not what you think of as success. All this is the probability of getting whatever you're looking for. In this, Ebola. If you get Ebola, that's a success. They have a population of some size. One person getting Ebola is a success. So what's the probability of success? And they actually use this calculation. In quality control, back to statistical process control, you get a box of parts, 100 pieces of something, whatever the part is. How do you know whether to accept that box or not? You take out 3 of them at random and you test them. So the probability of success is the probability of finding a defective part in the 3 that you selected. So out of a box of 100, how many ways can 3 come out so that 0, 1, 2, or 3 are defective? And you have to make a decision what you're going to accept. If none are defective out of the 3, you're going to accept it. If 3 come out defective, you're not going to accept it. What about 1 and 2? This is where the business decision comes in. We can give them the odds that that occurs, given that the part has a probability of being defective, but we can't tell them where to choose. 0 and 3, that's easy. All of them are bad, that's not good. None of them are bad, that's good. Binomial is 2 states, and one of the states is a success. And the probability can be from, it can be anything. It can be from 0 to 1. but generally the probability is somewhere around 0.3. This is the binomial probability. And in statistics, they usually use an X. The n combinations X is the number of ways it can come out. P is the probability of success, and it's raised to the power X. If I have 3 things that could be defective, P is the probability that they are defective, and I have it X times. 1 minus P is the probability of not succeeding, and n minus X is the number of not successes. So if I have a probability of success of 0.1, I have 10 things, and I want to know what the probability is of getting 3 successes with a chance of success of 0.1. This literally becomes 10 combinations 3, 0.1 to the third, 0.9 to the seventh. That's an official binomial probability. We don't have to calculate any of this. Pick a spot. This is equals B-I-N-O-M. Binom, binom.dist. 2 of the main ones, binom.dist, binom.inv. Binom.dist will give us the probability of S successes in N trials with a probability of success of S, and we have the option of cumulative or non-cumulative. I'm going to use this, what I have, 10.3.1, 3 successes, comma, 10 trials, comma, 0.1 is the probability of success, comma, and we're going to put in a 0. This means that we want exactly 3 successes out of 10 trials. That's what the 0 means. Cumulative means I want 0, 1, 2, or 3. 0 here, non-cumulative, means I want exactly 3. And the probability of that is 0.057. And it will give you a ridiculous number of decimals. Let's do this real fast. Put a 0, 0, 1, 2, 3, 4, and 5. This is the number of successes, and I'm going to do this out of 5 trials. And I want the individual probability of each of these. Equals binom.dist. The number of successes, I'm going to use the cell reference. I'm going to click on the 0, comma, the number of trials, I'm just going to enter 5. Probability of success, 0.1 is as good as any. 10% chance of success, and I want all individual. So if the probability of success is 10%, the probability that I have no successes is 0.59. If I copy this down, the probability of one success is 0.32, 0.33, 2 successes, 3 successes, 4 successes, etc. The cumulative, the 1, means suppose I want 2 or fewer successes, 2, 1, or 0 out of 5 trials. This is just the sum of those numbers. 0, 1, and 2. Yep, wrong way. So if I went right here and did equals binom.dist, two, comma 5, comma 0.1, comma 1. The 1 is cumulative, comma 1. And that's the addition. Individual is exactly what I put in. Cumulative is that number or less.